We'll just get started. So first off, thank the event organizers for this opportunity to share some perspective. The perspective that I kind of bring, based on which I kind of will be sharing today, is partly helping some organizations adopt SaaS into their solutions, primarily ISVs. I mean, we've been working with ISVs, helping them SaaSify, meaning take an existing solution which they've been selling as a conventional product, and then like kind of get that converted into a SaaS model, so that the whole software can be run as a service and can be sold in a service model rather than selling in a license model. So we've helped, I personally have helped a few companies with that in the past couple of years, past year and a half. And more recently, Progress, the company that I work for, we have been dabbling with SaaS for quite some time, almost like 10, 15 years. Though the term SaaS didn't exist, the subscription license, which is one key aspect in a SaaS model, you don't go off on a CPU-based license or a user-based license, perpetual license. It's more a subscription license per month or per year or per user month. So it's a time-based subscription license. So we've had a licensing model for a long time, and we have a lot of attributes that make our platform, the application platform, one of our products, conducive to build SaaS solutions. So based on this and looking at some of the use cases that we've come across, that's what I'll be sharing in today's session. More from an application standpoint, not so much from a platform vendor standpoint, more from someone trying to build a SaaS solution. Okay, just looking at where it typically, I mean, like any software, the context again for a SaaS, the primary context is someone trying to build a solution that's going to be used by multiple clients. It is not a custom project, though there are some use cases where SaaS fits in even in a custom project mode, but by and large it is in a solution vendor mode, an ISV that's building a solution. So the typical model is like where they go through the internal cycles, and once the release is ready, it goes off into each client. And then you would just go prepare the client environment, which is a completely different setup, basically a dedicated server. And on the server, prepare the application, configure, deploy, start, verify, and then goes into production. That's a typical application cycle. Now, this has been for a long time. I mean, software products is not exactly new. They've been around for quite some time. Packaged products or products which come with bulk of the shell and partly customized. Now, in the 90s, with the whole ASP model, there was outsourced hosting came into picture. So earlier the whole model was like there is someone that builds a solution, in-house or a solution vendor, and the built solution is taken to the production environment, which is a dedicated server managed by the client where the application is running. They don't run it outside. It is run in their own data centers. That was a typical model for a long time. And even today, probably a lot of the applications run in that model. They run in the captive data centers of the enterprises. But in the 90s, the whole external data center concept took off, partly driven by the dot-com boom. But it did catch some fancy. So wherein now there is a separation. The end client does not run the application in their premises. It's given off to someone else, a third party, to run it. It's just a data center. They're not application experts. They're not business experts. They just understand how to operate a data center. So part of the responsibility has been shifted out to a third party. Now, this is one of the kind of triggers for SaaS. The bigger trigger is the whole web-based solution architecture. It kind of simplified many things. First off, the web-based architecture uses the internet as a major fabric in the application architecture. It's not just like, unlike the previous older days where there were dumb terminals, or more recently where there were multi-tier applications with rich desktops. Rich client applications or fat client applications. Unlike those, all of which use just a simple network, some native protocols to connect from the client to the backend, maybe a database server or maybe a middle tier in some cases. They're all proprietary. But with the advent of web, it kind of simplified the models. More often, the users are almost always using browsers, very lightweight browsers. There is no connectivity or no software required on the desktop other than a browser. And the connectivity is a simple network connectivity. Whether it's intranet on the LAN or you're going to access an application on the internet, there is no extra connectivity required. Just a simple regular network connection is all that is required. And likewise, even in the middle tier, with the web becoming ubiquitous and there being a very easily available communication fabric, it became simpler to partition the application into multiple chunks. They're no longer monolithic application where, at best, like there are 3-tier applications where you have a huge middle tier and a database tier and a light front tier. Now with the web fabric, you could partition into some more. chunks. So some of the enablers, why it simplified the web models. Now, since there are chunks, the chunks can be built separately, can be installed separately, configured separately, deployed, started. Each chunk can be managed separately. The application is now composed of a lightweight UI in the browser, maybe one or more databases, and multiple chunks in between, each providing some part of the application functionality. Now, in this context, the moment we say there are chunks and there are independently installable and configurable parts, now they could conceivably be seen as something managed by a third party. Like it's not like if there is an independent chunk, well-defined interfaces, well-defined integration requirements, they can be run separately. But there's one of the enablers, key enablers, wherein like there's someone that builds the solution and can set up multiple instances, one instance for each client. This is one of the configurations that open up where with the web, the end enterprise that's actually getting the solution, all they need is a browser-based access. Now, since I'm accessing from a browser, it doesn't matter if I'm accessing the application in my network or somewhere outside. It is transparent to the end user. So this is one of the models that started gaining traction, and this is the basis for the whole software as a service, wherein like someone that is building the software hitherto would have been licensing it to me. If I'm an enterprise buying some solution, package solution, the models available until now were only pure license model. I just buy the license, and depending on the domain or the nature of solution, it could be CPU-based license or a user-based license, but by and large, it's a perpetual license. I buy it one time, and once I buy it, it is mine within the scope of the license in terms of number of CPUs and number of users. Now, there is a conventional model. Now, with this, now this opens up a new opportunity or new avenue for software distribution, wherein I don't buy it as a perpetual license. I subscribe to the service, right? So that's the whole. One of the most, if you look at it as a trigger, like hitting the knee, probably Salesforce.com was the biggest trigger, which made SaaS more palatable and popular. It's not often like there is a lot of paranoia within organizations to have their key business data residing somewhere outside. Now, Salesforce.com was managing core sales data, which could be like very sensitive information, and very rapidly after the whole offering came into picture, very rapidly enterprises started adopting it. Just because it offered a lot of other conveniences, there was a trade-off. You have to deal with the sensitivity of the data residing somewhere outside, your business data, key business data residing somewhere outside. But that was majorly offset by the ease of access. It is available outside the enterprise. You don't have to worry about security. Someone is taking care of it. It's accessible, ubiquitous anywhere over the net, which is the nature of the sales force. The sales force in any organization, the sales team is very mobile. They are very rarely sitting in the office. And they still need access to the system. They can't come back once a week to the office and file whatever happened the whole week. This is very kind of the value that they were getting much more than offset the trade-off or the concern with respect to the security. Now, as this started gaining traction, increasingly the enterprises were okay, depending on who is going to be providing the service, they were okay to consider having some of the key data running outside. I know of one, there's a company which has an anti-money laundering software. Now, they are one of those vendors that we helped convert their solution to service. Now, this software is sold to banks. And the data they deal with all the banking transactions. They detect fraudulent transactions, potential money laundering transactions among the transactions that occur in the bank or any financial firm. Now, this is key data. When you virtually get, if it's a bank, you get every transfer information, every account's balance, every account detail. That's pretty much all the data that a bank actually works with. And that data is available to this solution. And this solution is running as a service, accessible over the network, over the internet. Now, that's an indication, like depending on the credibility of whoever's running there's willingness to consider it now. So I guess Salesforce.com was the inflection point, which kind of made the whole notion of software as a service very palatable. And they, in many ways, also define what are the typical approaches to building software as a service. So in some of the definitions, it's still a little elusive. I mean, there are no well-defined attributes of SaaS. So some of the evolved attributes or what you can draw from existing solutions, IDC defines it as a network-based access. It's pretty much taken from the IDC definition, the first three lines. Network-based access to and management of commercially available software. So essentially, it's a solution vendor that's making the software available as a service. So it is commercially available software to begin with. And It is network-based access. That's the other key aspect. I don't want to deal with, since I don't want to deal with the software, installing, configuring, and operating the software, it has to be network-based access. So that's the most basic minimal definition of what SaaS is. It has to be centrally managed. That's the whole idea. I mean, if I'm letting someone else do it for me, I have to get something in return. And what I get is like the optimal functioning of the data center, which means there will be one small team or one central team that manages all instances for multiple clients. That's where we get the economies of scale and the increased efficiencies. Multi-tenanted, which is another attribute. It's not a necessity for SaaS. It's not necessary that the SaaS solutions have to be multi-tenanted. Multi-tenanted essentially means one instance of an application serving multiple clients. Each client looking at it as though it's their own instance. So there's a software design involved there where you have to build the abstraction of a client ID or an enterprise ID into pretty much all your data structures. Now that is not required, but that's another common attribute in at least considered when looking at SaaS solutions. And then the licensing model. By and large, SaaS solutions are a usage-based license, pay as you use or pay as you go. They are never perpetual licenses. I mean, it doesn't make any sense to have it perpetual license. So some of the use cases, ISPs, like I said, that's the key target segment that is looking at SaaS, are companies that are building solutions. Today, I mean, the ISPs essentially can build any kind of solution. It could be an infrastructure product, or it could be a business product, or an end application, or it could be a framework tool, it could be anything. But the space where SaaS is gaining traction is in the end business applications. Solution vendors, independent solution vendors that are building business applications. It could be a banking software, it could be a Salesforce tracking, or could be a CRM software, could be anything. But essentially end business solutions. That's one of the primary target use case where SaaS is a serious possibility. There are serious value proposition, a serious case can be made out for such solutions. That is not to say like other solutions cannot be in SaaS, but that's one of the primary target spaces where SaaS makes a lot of sense. Just for instance, like if you're selling like this, in the same the anti-money laundering case, if they were the whole scenario came up when they were selling into smaller banks. Now the smaller banks, most countries have a regulation now that the financial institutions have to run anti-money laundering software, and if it's a small bank, they can't deal with every new software that they acquire is extra burden on them in terms of their operational IT team, and so they want to deal with as less as possible. And this was somewhere they literally are not going to be there just meeting a regulatory requirement. And so long as all the regulatory triggers are modeled in the software, they don't have to customize it. So this is a perfect case where it just makes sense to take it as a service. So where it's hassle-free. You don't have to buy license, you don't have to buy hardware, you don't have to buy software, you don't have to figure out how they all work together, no configuration, no production operations, nothing. It's just, you just use it and pay for it. So ISPs is one key target segment. And some of the, like SaaS also gives some flexibility in terms of putting to, like if you look at, like there are multiple solutions in the organizations and there are very fluid interactions involved. It is not predictable, not very static, so to speak, that you can do once and have some static releases, periodic releases of updates. It's very, very fluid. Again, in such environments, the whole service model makes sense. So each of the application modules can be running as a service. This could be within the organizations also. And even within, like if you take the BPO industry, for instance, they would need to access like maybe a case tracking system. Like there's a support case tracking system which is being offloaded to a third party in a BPO model. But it makes sense for them to be accessing something as a service. Because like the BPO gets access to it and also the end enterprise client, the BPO's client also gets access to it. So there are again some other business drivers where it's actually desirable that the solution be outside the network and be hassle-free. No one owns it. Like I mean, the BPO is not dependent on the enterprise is not dependent on the BPO, and there's someone else which both of them agree upon that's actually running this, the whole solution. That's yet another driver. In the enterprise, again, you can look at, especially with the whole server virtualization platforms coming up, even in the enterprise, there are possible cases where there's a single application that needs to have multiple instances. So even if it's not in a third-party SaaS model, it could be an internal SaaS model. So it is a consideration for any application that can have multiple instances, which is very common. I mean, you come across a lot of cases where like there are, like say, warehousing solution. Could be one per warehouse. And today it will be set up on dedicated boxes. And you could look at alternate approaches where it does not have to be dedicated boxes, like where it's one server with one instance of the application and the database running for each warehouse. And having multiple warehouses and multiple independent warehouse solutions is very common. So there could be such cases where it's a single application and multiple instances. So even within the enterprise, it's a consideration now when defining application architectures. Some of the views of SaaS, I mean, like there are different people involved. I mean, there's a development team. Development team has a view of SaaS. And development team's view of SaaS is like, it doesn't change much other than the fact that if at all you look at multi-tenancy, then there's one consideration. So there are some design considerations involved, but beyond that, in most cases, it doesn't have much of an impact on the development team. If you go for the most basic deployment model where it's just, I just have a third party managing my instances, I don't care how they do it. They could even just have one independent instance for each client, including the application and the database. So in the most minimal case, the solution developer's view is, it's no different from their normal deployment. In the ideal case, if they have done well, then there are some design considerations, especially for multi-tenancy and for ease of configurability. Now I'm looking at the ease of configurability. From a flexibility, it is required anyway. If I have a package solution that I'm selling to multiple clients, I have to allow the clients to configure it. Now, when it comes to a SaaS model, we are talking about, especially if it's a multi-tenanted, where I have one instance servicing multiple clients, then the configurability challenge is slightly higher. So when multi-tenancy comes into play, then there are serious functional and design considerations that come into the picture from a solution developer standpoint. From a production team standpoint, it's by and large, like it is the solution developer themselves are running it as a service, or they're giving it to someone else to run it as a service. But there's another party or another organization that is running the actual service, production, managing the instances and managing the clients and the access and the uptime and the whole works. The production team view again is probably not too different from if it's a data center, whether they're running 10 applications on 10 boxes or 10 applications on 10 instances on one box, or 10 applications as 10 views on a single instance. From their standpoint, there's not much of a difference. From production team standpoint, maybe there's some configuration impact. Otherwise, it's the usual, the tasks are pretty normal tasks. You have to manage make sure the hardware is up, make sure the operating system is up, make sure the backup recovery, the usual tasks. So production team's view is probably not too different from what they would do, so long as, as you look at it from a data center standpoint. End client view is very different. If from an end enterprise, like if you look at the decision makers that are trying to acquire the solution, now they have a serious option. Like if you look at buying a conventional software as a license, now you have to deal with everything. The vendor will tell you that this is my specification, my configuration requirements. You need to buy at least a 4 CPU hardware. We need to have for redundancy, you need to have a 2-node cluster, and I need this a J2E application, so I need an app server. I'm certified only on this app server and this version of this app server, and I work with these 2 databases. They give a whole set of what is the valid configuration. I have to go analyze all that and buy the hardware, buy the software, buy all the stuff that I need, and probably there's some integration involved, definitely there's configuration involved. The whole conventional model. Now compare that with the SaaS model where I just decide, I anyway have to evaluate the solution in both cases. I evaluate the solution, if I like it, I sign up. I don't have any other hassle. Because the solution provider itself is providing it as a service. So all the responsibility shifts to the solution provider now. Someone has to do this. I mean, there's no getting away from the fact that you need hardware, software, and the versions and integration, all that is required. But it shifts to someone else, and that someone else may be managing it once for multiple clients. So it's kind of, we shift the responsibility to someone that can do it better. So the management views now, there are serious options. So you have to see the pros and cons. There are cases where you want to have it running inside the enterprise. And there are cases you don't mind having it running outside. If it's running outside, then the whole credibility factor comes into play. Because you're looking at business data that's running in some data center, not in your control. Now then there's integration involved, integration requirements. Like even in Salesforce.com, as long as it's running just as a service, it was not really, it was just there. I mean, it was a web-based software. Now, some of the SaaS attributes became much more prominent once Salesforce.com started getting integrated into other applications in the organization. So you have data flowing from your other corporate applications into Salesforce.com, and likewise you have data being pulled from Salesforce.com from your other, maybe some reporting application or a business monitoring or maybe like a CEO dashboard. Could be any kind of applications. The requirements start coming up where you have other enterprise applications that need to pull data from a hosted application, from a service, software as a service solution. Now, this kind of it is the whole visibility into what SaaS is about. Now, which is a requirement, right? It's very rarely that you will come across solutions that can be completely self-contained, with no other dependency on anything else I do within the enterprise. There would be often some mitigation requirements. That becomes another consideration. If I have it on my machine, it's in my control. If I'm having someone else running it, then I have to depend on that company or that organization to take care of the integration. So there are some trade-offs. So the management view, when deciding on solutions, there are some serious considerations. The end user's view is the least impacted. I mean, these days, almost any application, it's a given. It is a browser-based UI. I mean, you have to have extremely strong reasons to go for native UI. So bulk of the applications fit into the browser-based UI. The moment it is browser-based UI, as an end user, it doesn't matter where it is getting served off. For me, it's always a URL. And like that could be on the network, could be outside the network. It doesn't really matter. So long as web-based UI, the end user's view is the most minimal view. I mean, minimal change from whether it is hosted locally or acquired as a service. Either way, the end user's view is the one that is almost nearly identical. So some of the approaches. Today, SaaS, like maybe a few years down the line, it will change. Like we will look at new solutions, ground up being considered for, considered in a SaaS model. Today, at least in the current phase, it is more existing solutions that are being re-engineered for SaaS. So, there's the factor or the factors that come into play are a little different in this. So again, just to define some of the attributes of SaaS, it is web-based, meaning browser-based. That's one requirement. If you have to run it on the internet, the only well-accepted protocol is the HTTP protocol. So you can theoretically, you can look at having a rich client running on every desktop. But those are again painful models. If you look at the most common model and the least hassle-free or the most hassle-free model, then the application UI is web-based. And then the whole ease of acquisition is another attribute. Like I said, like any company that decides, evaluate the solution, and if you like it, you just acquire it and start using it. It's almost as simple as that. There is no kind of waiting time or no installation, no setup, no configuration, no application, no monitoring, no tuning. These are some of the attributes in terms of from someone trying to adopt SaaS. Now, regardless of how it is done, some of the roles are running. Like you will have the developer, you will have to have someone managing the product functionality. Someone should understand and manage the business functionality. You'll need to have an admin, someone managing the installation, configuration. Pretty much all of those remain. From a like the infrastructure standpoint, again, all of the common infrastructure is required. You have an application server, you will need to have a database server. You may need to have some integration, like if at all some integration layer, you need to have some integration software required. It runs on some hardware, on some operating system, on some JVM, if it's a Java-based solution. So pretty much the basic attributes of the solution doesn't change. What changes is who's doing what. So what typically is distributed between the solution vendor and the enterprise now becomes completely solution vendor. The enterprise hardly has to do anything. Maybe at most some defining some business rules or some configuration parameters. Beyond that, the enterprise doesn't do anything. So it's just shifting of some of the roles. So in effect, like SaaS is an outsourcing of a solution. Like I don't care how you do it. I just want this application available to me all the time based on some SLAs. Now it is pretty much like the whole thing is outsourced to someone as a third party. Now ASP, often this question comes up, like why is SaaS different from ASP? How many of you are aware of ASP? Have heard of, not the .NET ASP, the application service providers? Okay, it's I think for a good reason, most of this room doesn't know it. It was fairly kind of a major buzzword in the late 90s. And there were a lot of companies that were formed with just an ASP model. They were setting up huge data centers. And the whole idea of setting data centers was like the ASP way will take off in a very big way, and almost all enterprise applications will be run in third-party like ASP providers. There was expectations. And a lot of data centers came up, huge money went in, and along with the dot-com burst, that whole thing went away. It went away so bad that the term doesn't even exist anymore. But the model was not too different. Even in an ASP model, basic model, though there are some fundamental differences, the basic model was like someone builds the application and I don't run it in my data center. I give it off to someone else to run it. The only difference is in the ASP case, it doesn't matter whose application it is. It's by and large an enterprise application. Like it's a one-off case. Like someone that needs an application gives it an ASP to manage it for you. In the SaaS model, that basic attribute is still the same. The application is being run by someone else. But who's running it is the difference here. In SaaS case, the solution provider, that organization itself runs the service. And for multiple clients. ASP does not run for multiple clients. It is essentially like each instance is a dedicated instance. I get my own hardware, I get my own solution stack, my own application, and running for me. It's just that someone is doing the system administration and the network administration, the whole admin and production operations is taken care of by someone else. Otherwise, it is exactly like that machine is running in my enterprise, within my data center. In a SaaS model, the whole, it's completely virtualized. I don't know what is running. I don't see binary ever. I don't see a platform requirement ever. I don't see any integration. I don't see anything. I just get access to the functionality that I need. So there are some, the view and the usage is different in the case of SaaS when compared to ASP. So some of the, when looking at SaaS solutions, especially if we're trying to re-engineer, some of the attributes that need to be considered, like I said, again, repeat, web-based. If not web-based, then there are other challenges. So that's not that well conducive for a SaaS re-engineering. You need to build in easily configurable and user customizations. Which again, like I said, it is a more common requirement if it's a product. Even if I'm selling it in license mode, I need to provide configurability. I can't say you need to change something you just tell me and I'll change the Java files for you and give it to you. You have to have most of the common configurations and common customizations. You should make it easy for the end user to do it. That is required anyway in any solution. It's required a little bit more in a SaaS scenario because the client never sees the software. If I have the software, I see the configuration files, then you can even tell open this file and locate this line and change it. That instruction is okay if it is a licensed product. In a software service, they don't see those files ever. So there's an extra emphasis on the ease of configurability because the end enterprise never sees the software, meaning they don't get hold of the binaries or the configuration files or the installation directory. So the configurability and end user customizations is one major consideration while SaaS re-engineering. It has to be centrally managed. If it requires the administration, when I say centrally, with some common, it has to be web-based, for instance. You don't want to have multiple instances. You can't, for every small thing, you can't be expected to go sit at the console of the server. So a web-based administration is an important requirement. It's one more reason why it should be web-based. There are some parts of the administration which the enterprise also may want to do. Maybe from, say, security, for instance. So there's some part of the administration which is conventional administration, which may have to be shared between the SaaS provider and the end client enterprise. So it has to be remotely managed. And multi-tenanted, like I said, that's a consideration. An ideal SaaS application should be multi-tenanted, meaning one instance should be able to service multiple enterprises, with each enterprise looking at it as though it is their own solution. That is the key. I can't say okay, filter, if it's a bank solution, I can't everywhere say I can see all bank data. I mean, it is ridiculous, right? I mean, there's a whole privacy issue. So each enterprise should look at the application as though it's their enterprise applications only. If I go somewhere, look at the users, I should see only my organization's users. If I look at the account, I only should see my organization's accounts. Everything, it should look as though it is their solution. But on the back end, one instance might be servicing multiple enterprises. So multi-tenancy comes, that's one of the most complex from an application architecture and design standpoint. That's one of the most complex considerations when it comes to SaaS. Though like I said, it's not necessary. But that's the most optimal scenario, where a single instance can service multiple enterprises. In terms of enabling SaaS, if I have an existing application and I want to SaaS enable, there could be more. These are some of the ones that we have come across in terms of what makes sense and also where there was some traction. The first one is, like I said, from an end user, as an end enterprise trying to acquire a SaaS solution, it doesn't really matter in which mode it runs. My view is the same. I get access to my functionality from browsers. And that's about it. Beyond that, what is running, it doesn't matter. Now you can, if as an enterprise I say, this is my requirement. And if you have to service it, the simplest way to service it is you go get a hardware for each client. Every time a new enterprise signs in a SaaS model, you go get a 2 CPU box, app server, 1 2 CPU database server. Set it up and tell me this is the URL you need to access. Whatever, saas.com/my company name. Now, if you run it as a completely self-contained instances, each instance is on a separate hardware, separate installation, separate configuration, I won't know the difference. You run it in that mode, or you run it in a multi-tenanted mode, I will not know the difference as an end enterprise. My view remains the same. So this is the simplest form where I don't change the application at all. Take the application as it is, instead of the client doing it, I do it for the client in my own data center. Whatever the client would have needed to do, I do it, and offer it as a service. That is the most basic model, but also the most expensive model. If I'm going to be running it in a service mode, and if I have dedicated hardware for each client, that's not the best use of my resources. And if I have to maintain, if I have 10 clients and I have to maintain 10 such setup, it's 10 times the system administration load for me. If I can manage it in one instance, there is that much lesser load for me. And then, of course, the more fundamental issue of cost. 10 instances is 10 times the hardware cost and 10 times the license cost. It's not a so you don't have to be that mode. But if push comes to shove and there is urgent need to do it, it is SaaS. No one can question that. Like I said, as the enterprise views it, it is SaaS, software available as a service. That's the most basic level. The next is like the application as it is. You don't need application much. Most applications databases provide a very natural unit of partitioning. If I can have the same application instance, but somehow switch the database schema, have multiple databases based on some criteria, like you switch the database schema, then the application does not have to change. And it's very minimal re-engineering. There are simple ways of doing it. Like for instance, one client, what we did is like they had a very good connection abstraction layer. They were not even using the App Store connections directly. They had their own connection wrapper. Now, what they do to SaaS enable there was into the connection wrapper, build a schema switch. Like based on the user logging in, we have to have one common user database. So based on the user logging in, we pick which company that user is from. Moment we pick the company, we know which schema we should set it. Then we set a variable in the connection wrapper. From that point on, anywhere in the application a connection is requested, we set the schema and return the connection. Now the rest of the application did not even know the difference. It was working as though it was a single client, single instance, dedicated instance mode. The whole thing was localized to just this one small connection handling layer. So there are simple possibilities. So where you can optimize on, now you're optimizing a license. You have one app server instance, you have one database instance. In a database, you can have multiple schemas. Or maybe in some case, maybe you want to have multiple databases itself, but the simplest form would be to have multiple schemas in the same database. So you optimize both the licenses. You have the same app server license that can service multiple clients, and same database server license, how many ever, 2 CPU, whatever you got, that can service multiple clients. So this is the second model with minimal re-engineering, and but then there is one instance for each end client. The third one is, the second one was like multiple DBs. The third one is where it is one instance with multiple schemas in a single database instance. I got the two mixed up. And the fourth one is the complete multi-tenancy mode, where I have one application, one database, one schema. And so you have to, in the fourth case where you have to do the maximum re-engineering. That's where multi-tenancy is explicitly built into the application itself. In the level 2 and level 3, it is kind of implicitly built in. I mean, like in the sense like by most of the application doesn't even know it's multi-tenanted. We do a schema switching. So once you switch the schema, like the database itself is completely partitioned. In the fourth case, like there's no partition database. So which means like in most of my tables, I will need to have a client ID column. Now, from an application architecture standpoint, if you're trying to look at SaaS engineering, it has to be tiered, it has to have some facades. See, like especially when you're running it in a SaaS mode, the integration becomes a slightly bigger challenge. And you will have integration requirements. Like I said, like if not for anything else, just for simple reporting purposes. Like in the enterprise, like if I'm running, whatever I'm running is a business software. And if it is business software, that data has to fit into some enterprise reports and have to fit in with other data. So which means like it will never be sufficient if you get reports from that system alone. The data has to come and get integrated with some other data before you get the report that the enterprise needs. So there will be, in the minimum, there will be reporting requirements, and most often there will be more than that. Integration requirements could be more than that. Could be data feeds coming in, could be data being extracted for some other purposes by other applications. It could be any sort of, so the application should be ready for integration, both inbound and outbound. From an inbound integration standpoint, you have to have well-defined facades. And from an outbound integration standpoint, it has to be a consideration in the whole application. And the whole web-based UI, I mean, which is a given today, but still, web-based UI is a necessity when you look at SaaS. So the whole layer, the tiered application is one of the enabling factors. UI, like if you look at web-based UI is fine. I mean, that's a minimum required. But again, today, web-based UI has a whole, this is a decision tree that we have built for our own clients. I just plugged it in here. So there are like a browser-based UI can be just a simple browser-based UI or can be rich, more richer UI, the emerging Web 2 based models, where I have a richer browser-based UI. Now, if I want richer UI, it could be browser-based, simple browser-based, or it could be rich desktop-based. Like the Adobe Air platform or like the Pramati Deco platform or Microsoft Silverlight. There are many platforms coming up which have a stronger desktop. There's a component. Silverlight doesn't need a desktop component, but at least Adobe Air requires a desktop installation. I have to install some software on the desktop. Now, there was a time where we thought that's a taboo. If you have to install anything on the desktop, that's a strict no. But with some of the flexibility that these platforms provide, especially from like say offline, I can access applications in offline mode. So there are some things that these platforms provide, and still by and large it's web-based. The end user's view is no different. The end user access from the browser too. It's just that from the browser, the user is accessing something running on the desktop itself and not on the network. And the component running on the desktop accesses other things on the network. It's an emerging platform, and there are cases where there is a need for running the richer desktop platforms. So there are multiple, the decision tree is a little bit more involved now, even for a web-based UI. So there's some of the, I'm not going to go too much, like for instance, Ajax is a given today. Again, most of these considerations have nothing to do with SaaS per se. It's just that they become a little bit more relevant in a SaaS model because the web-based UI is a necessity. But otherwise, a lot of these are, like any application UI, many of these considerations will come into play. Data access, like I said, I'll just quickly restate. So it could be like I said, one dedicated database per client, or it could be one database but multiple instances per client, multiple schemas per client, or one schema, one set of tables being able to address multiple clients. In all cases, the client's view is a completely partitioned view of data. When I log in, I should never ever see any other client's data. Meaning as an enterprise, I only should see my organization's data. That's a given. In all the modes that have to be supported. But these are some of the modes possible. Like I said, the connection switching case was the one that we did for this anti-money laundering solution. So where their solution was ready for it. There was a connection layer that they were very, very strictly following. And it was their own wrapper. So that made it very simple. The whole thing was done in a few days. And then quite some time to test it and make sure everything is okay. But the actual change was very minimal. So maybe it's possible. So it depends on the application. So you should explore what kind of data access layer. The metadata-driven configurability, like I said, the whole ease of configurability when multiple clients come in without needing access to the installation or the software or any of the configuration files is the key. So there's one consideration that comes into play. So we have to enable some additional functionality into the whole solution to enable simple configurability. And some could be from the SaaS provider standpoint, but most of it from the end user standpoint, the end enterprise client. When it comes to multi-tenancy, like I said, we already discussed the whole data management, the tenant management, the provisioning. In terms of if I have one hardware, if I have dedicated hardware, then it's a straightforward. I mean, if I need more processing power, I have to get either bigger hardware or cluster it or do something. But if I have a shared resource, then the tenant management in terms of resource consumption is a key problem. It's not a software problem, meaning it's not an application design problem. It is more like a platform problem. But there is a consideration, one way or the other. If the platform is not providing it, then I should build it into my software. I should be able to say, okay, this client has so many licenses, so should get 40% of my resource time. This one is a smaller client, should only get 10% of my time. Now, how to do it depends. Like I said, if the hardware provides provisioning at that level, straightforward. If the hardware doesn't allow, then you have to build it into the application itself in terms of how to provision. So tenant management is one aspect, and of course the whole security. Like I said, the privacy is a non-negotiable. The data that any enterprise sees should be only theirs, and they should not be able to see any other enterprise's data. So that brings its own challenges. When you have a shared application instance servicing multiple clients, make sure the privacy is there and the access security is there is one consideration, key consideration. Like I said, the integration is a very common, though it's running in a hosted mode, I should be able to integrate. So that's again another consideration while looking at SaaS reengineering of any existing solution. And the integration has both inbound and outbound. There should be some other application in the enterprise needs either some service from me or some data from me, if I am the SaaS provider. And likewise, for things that I do, I may need to get data from the organization. Like you may need to get feeds. Could be like transaction feeds or could be any kind of feeds. Even for my functions that I'm providing, I may need to get data. So there's both inbound that I pull and there's outbound that I push. Or someone is invoking a service. So it's both inbound and outbound. So those layers, it's a standard integration problem. It's nothing to do with SaaS per se. It's just that in this case, it has to be coarse-grained and well thought out. Since it is the need is going to be high, but need is going to be high and at a very, very coarse-grained level. It's not going to be too deep. I'm never going to go probably never ever going to go ask for a row in the table. I may not even know what table it is. So it's going to be mostly at a business level. Both the inbound and outbound, the integration requirement is going to be at a business level. That needs to be considered when defining or designing the whole SaaS reengineering. See, the enterprise 2.0, sorry if it's not too clear, it's like little hazy, but there's a very distributed enterprise today. If you look at the enterprise 2.0, with the Web 2.0 is rapidly coming into the enterprise, where it is like the user participation is quite high. It's no longer where it is a point-to-point. I have one end-user client accessing one application. It's whole web of solutions in the enterprise, and there's a lot of interaction. Could be from a services backbone, and more often from mashups and such in the front end. So it's a very fluid organization IT scenario with a lot of interactions. Now the whole SaaS have to fit into this enterprise, and given that it is so fluid, in some ways some of the SaaS attributes are like incentives to get a solution in a SaaS model. Like if you're looking at a very fluid organization where there's a lot of interactions involved, you don't want to deal with any rigid setup in terms of hardware or software or stack, so it makes it easier. So you decide on a new solution, just evaluate the options available in the market, pick one, and then just get it. It's available. And it's available in a way where you have your interfaces, because all the SaaS providers have to enable the integration. So for me, I get an end user view, which is through the browser. I have all the functionality I need. I have inbound services if I need to access data. I have services that are exposed, and the SaaS solution tells me how I should feed data if I have to feed any data. The interfaces are defined, inbound and outbound, and the application access is through web. It fits in very quickly and seamlessly into the emerging Enterprise 2.0 scenario. Enterprise 2.0 in terms of how the enterprise IT is looking today in the Enterprise 2.0 with the advent of Web 2.0 in the enterprise. So these are some of the steps that kind of typically goes if you have to look at adopting SaaS. First off, make sure there's a need if to SaaS reengineer a solution. I mean, there's an existing solution. There has to be a need for SaaS reengineering. And like I said, the attributes of the application have to be assessed. Maybe it's too complex to run it in a SaaS mode, which means you have to go on a single dedicated server. Even if I'm running it as a service, I have to run it on dedicated servers. I mean, the whole reengineering exercise is to get it running on a single server. There are all the requirements. If not, it's a no-brainer. Meaning, like I said, instead of the end client buying the licenses, buying the hardware and software, and installing and configuring, you will do it for them. So that's a no-brainer. This whole thing is about where there is re-engineering to get it running on a shared server, on a single server without requiring multiple installations. So we need to evaluate if the product is ready in terms of the current design. The pilot phase will be the minimal re-engineering. I mean, go for no point going for a full-blown data re-engineering, in terms of getting the client ID into every table, for instance, like the organization ID into every table. It's massive re-engineering. Now, so that is an extreme step. I think the starting point should be a more minimal pilot. Look for what is the best way to get the notion of, even if it's not the most optimal way from a resource consumption standpoint, but be able to share the hardware, share the software, and then try and get the abstractions in a minimal pilot. And only then go for the complete multi-tenancy. Whatever it takes. If it goes all the way till kind of engineering the multi-tenancy into the data itself, that's an extreme, but if that's what's required, so that should be the next step. The server virtualization, like I said, one of the requirements is dynamic provisioning. Like if I'm running it as a service, I will tell like we get, earlier we used to get from some of the banks, festival season, they have some solutions in kind of customer facing solutions, and during holiday season they get surges in loads. Like for instance, ICICI has this whole gold scheme. Now during the the Diwali and 2-3 times a year, they get a surge in gold buying. Now they prepare all the vendors upfront. They say that this weekend we will have very high loads. So you should be on standby. Now, the whole system, they get probably 4 or 5 times the normal load on those weekends, which happens total of maybe 4 or 5 days a year. But the system is sized for that load. And rest of the year, remaining 350 days in the year, it's at about 15-20% utilization. Now, that's not the best utilization of the resources. Now, dynamic provisioning says that I can provision just that, whatever, 2 units of resource that I need for most of the year, and during those weekends alone, I can go provision 10 units. Now, the whole server virtualization is a key consideration and key accelerator in terms of SaaS adoption. It makes it that much more easier to look at SaaS models. So that's one. We'll look a little bit more in a few slides. And dynamic auto provisioning. I mean, that is taking the whole server provisioning to a next level where you can detect loads and like automatically dynamically provision additional hardware. Like maybe there's an SLA with the client saying like at any given point you should service my request within so and so time. Now, and to make sure you deliver those requests, either you override it or you like detect when you're nearing the thresholds and immediately provision additional hardware. So these are varying levels. I mean, so dynamic auto provisioning is an extreme case of SaaS adoption. So in terms of platform, like I said, the most common platform is, of course, the data center that the SaaS provider itself operates, their own data center, and then they operate it to the best extent they can. Like I said, in the most minimal case, it is one set hardware per client, and in the ideal case, it is one instance servicing multiple clients or anywhere in between. But it runs in the end enterprise's data center. I'm sorry, in the solution providers, the SaaS providers' data center. Now, this data center, like I said, the virtualization. How many of you have heard of or used VMware? Okay, I'm sure a year from now the answer should be more. I'm sure there'll be more number of people. It's increasingly gaining traction. I mean, like it's just the flexibility it provides in terms of virtualizing the whole hardware. You can have multiple logical images, and like you can start at any point. You provision the required hardware unit, and you can start any image. It's almost like you bought a new hardware and you got all the required software and everything set up on it already. So the hardware image is stored separately, and you provision the resources, and then you start an image. And what the provision could be any unit. Like the machine may have like 8 CPUs, but some capability. But you can provision like half of the CPU or like 2 CPUs or 4 CPUs equivalent, and it's amazingly powerful. And all that you can do declaratively. There's no programming involved. It's gaining extremely. VMware is one of the more popular names, but there are other vendors as well. The whole server virtualization is gaining a lot of traction in enterprise data centers. Like that's being looked upon increasingly as a very effective way of optimizing resource consumption from a hardware standpoint. Now, these platforms are available, like I said, they're available for anyone to use. So even a SaaS provider should get the virtualization platform and use that as the layer, the operating system layer. It provides the OS abstraction, so your OS images sits on top of it. And on what it is running is virtualized. So I can have one physical box, but I can make it look like there are 10 logical boxes. And each box, like I've said, like this box is equivalent to this CPU, this memory, and this network bandwidth. And that is available, and then I run something on that. And the resource provision, the CPU, memory, and bandwidth, or even storage, is made available for that particular instance all the time. So the virtualization is an important consideration even from a own data center standpoint, which also helps deliver on some of the expectations in terms of SLAs and such. The one that is gaining a lot of traction, how many of you have heard of Amazon's EC2 platform? In fact, there's a talk right this instant happening in the other hall. Dinesh Varia is talking about it. Have you heard of Amazon's EC2 platform? Cloud computing? Okay, so there are many of them coming up, but the one that is, again, amongst all of them, the one that is kind of getting some traction is the Amazon's EC2 platform. Application pre-deployed or running. So when you start the image, it will start the OS, it will start the app server, and start the application. It's up and running. So your boot file could be anything. It's a very powerful, and the unit of provisioning is very, very. I think you can go to seconds or minutes. I forgot, but if not seconds, it's definitely minutes. And so the very, very flexible web-based provisioning platform. And that's again an important consideration from platforms. If you're looking at SaaS. So you can even completely offer, even as a SaaS provider, if I am the solution vendor, I have options where I don't even need to run a data center. I can leverage the third-party virtualized platform and still get extreme flexibility in terms of the guarantees that I get from resource standpoint. So just a quick in terms of what it means to virtualize, as load increases, Like either sysadmin could monitor and do something about it, or in the more often case, you can dynamically provision. I mean, of course, sysadmin should see it. The auto provisioning is a more complex scenario, like I said earlier. But once the load is noticed, on the fly, you can provision a new machine. Like it can happen like in a span of like few seconds to getting the machine, and then what are the boot time it takes. Like to start an app server, start the instance, start the application, maybe it takes 1 or 2 minutes. That's about the time it takes to start the new instance. So it can very quickly get more instances onto the into the whole solution cluster. So the elastic computing or the cloud computing is now extending all the way up to the application itself. It's not just from an hardware standpoint. You can, in a SaaS model, you can even make it available at the service or the application, the solution itself can be elastic. And so you can, such platforms enable giving stronger SLAs at a much lower resource investment. Like I said, like guaranteeing SLAs always means that you over-configure. Now with the elastic computing platforms, you don't have to over-configure. You just have to have very good detection. You have to identify well-defined, very smartly identify the thresholds and have detection mechanism when the thresholds are reached so that you can provision the additional resource. And you don't have to over-configure for the worst case scenario. And then some of the scaling strategies, like there are, like in terms of, say, high availability, for instance, platforms such as EC2 alone, I mean, I can replicate into, again, a web-based, it's all network storage. I mean, I don't have a single device. So you can replicate, you're anyway storing data on the network, or somewhere in the cloud. You can also store the replicate image on the cloud, and you can have read-only images. I can have one image, multiple applications accessing it. So I have my primary app instance accessing it, and then I have a reporting app instance. So that it offers, like, since it's all on the cloud, very virtual, very easy to access, it enables a lot of kind of flexibility in terms of how you can scale. Like if I have an access which is one application instance is doing the OLTP transactional access, and there are 2 other reporting or read-only access, I'm scaling. If my load is such, most of my load is read-only load, and very little of my load is actually modifying data, this configuration works. And the whole ubiquity of the various components is the key here, which enables it. Going a step further, like I said, like the starting point today is that I have existing solution that I want to re-engineer, right? But in a year or 2, it may change. Now, yes, as new solutions come up, now this becomes a serious consideration even when I'm designing the solution. It's not about re-engineering. When I look at a new solution, you can look at SaaS even from the word go. Then the platform as a service is another option. Now, can I go dynamically? Can I compose my applications on the net itself? There's a platform available, and on the net, I go and compose what I need. Now, there are some use cases where, especially from a business process orchestration standpoint, I have a bunch of services available. As an end user, I can go orchestrate what I need. So there are some use cases, but the platform as a service is slowly gaining traction. For instance, Apex platform, have any of you heard of Apex? Again, it's from salesforce.com. So they have an application platform now. You can build applications on their platform without actually going, you never see that you're just doing the whole thing on the web. You design it on the web, define, implement, run everything. You don't ever actually install anything. And the platform is available, but in their case, it is more relating to the business they are in. There are a bunch of business functionality that they made available as kind of fine-grained components, using which you can compose your actual business flows. So there are some platforms already coming up. So this, okay, I'm almost at the end of my time. Like this just shows about, like, just a quick summary of the difference between ASP, SaaS, and PaaS in terms of who does what. Okay, I will skip this. That's one. Okay, going a step further, like if you look at the whole cloud, I'll wrap with this. There's a few more, but this last thought, I will just wrap with this. Now, with the complete Web 2 coming into play, the browser, the whole web has become that much more richer now. Like I said earlier, it was in a peer-to-peer mode. I have one browser, one user accessing one application. It's always like, there could be any number of users, any number of applications, but any given point, any given instant, it is point to point. There's one user accessing one application. That's how the web was. So it's a whole bunch of point-to-point links. There were very rarely any transitive links, meaning I go somewhere, from there you go elsewhere, or putting together stuff. All that didn't exist earlier. Or I can't even go modify stuff on the internet. With Web 2, I have start happening. So the user is more in the middle of things, and the web itself is truly a web of functionality and no longer just a simple networking fabric. Now, what does it mean for SaaS? If you look at it, like even in a SaaS environment, the moment, why should I look at complete applications as a service? I can break it down. Like just kind of look at some synergy between SOA and SaaS. Like I break the application functionality into smaller, finer grained services, so to speak, make it available on the cloud. The moment I have it in the fabric, I don't care where it's running. All I need to know is like how I access it. Now, with a bunch of fine-grained services, you could look at simple orchestration mechanisms where I can go and compose my business process. So an end enterprise that is not acquiring a complete solution on the web, it's acquiring the ability to compose the solution on the web. So you just get a simple, which means I still don't need to install anything. The whole thing runs on the web. But what I compose, my specific business flows, I can do it very easily because I just do a simple business process. And the step itself, the actual service components, they're all on the fabric again. So this is one it's not that it's happening today, but this is something that could happen. And in our, at least when we look at where SaaS is heading, this is one of our key considerations. We're also an integration company. Progress has the whole ESB platform. So we're looking at that as a key driver going forward, like where the application model in enterprise is going to change. And in many ways, the whole cloud computing, the momentum behind cloud computing in the enterprise. When I say cloud computing, I'm not talking about like the Amazon EC2 model. I'm talking about the whole enterprise itself being a cloud. So this is like something that we should watch, and it could kind of rapidly emerge. It fits into the standard SOA model. So I have like the promise of SOA, which unfortunately probably is not still fully delivered, is that like I can easily orchestrate and change my business flows. Now that requires a body of services available. The moment I have body of services available, the services could also be in a SaaS model. Like it's just the boundaries are getting blurred. What is SOA and SaaS can get blurred in this whole, this is a space to watch. And taking it a step further, it could come to an extreme case where as an end user, I can define my own business flows. See, like in any organization, every employee or every person in the organization has some well-defined responsibility that they have to deliver. The software and the tools, like IT systems, are only enablers in delivering their job. But what they do, they know. And it's ultimately each person's responsibility to deliver what they have to do. Now, invert the view, why should there be prescriptive systems that the users have to use? Why can't we like make some body of services available, functionality available, and let the user compose the specific flows they need? Which fits into like, I mean, when someone defined what their job function is, don't always go modify the IT systems to service the job function. There's always a delta. And the delta could be significant at some time. So they find workarounds. Often like working on multiple windows, for instance. I go to one system, do something. I alt-tab another system and do something else. Now, it's conceivable that you can give the flexibility to the end user where the end user can go define the flows. Because each one has their own like process of working. They can take it a step further and then actually model it in the system and use that as their automated flow. Possible. I mean, but definitely not happening today, but may happen for some time. I'll just wrap quickly with a little about progress. I can take questions. I believe that I'm not going to talk to it. But we are essentially an application and integration infrastructure company. We have both services integration and data integration, a bunch of products. And we, like Sonic ESB is one of our products, and a whole bunch of other products. I will just leave this on the slide. I can take any questions. So I've been getting markers saying the time's up. Yeah.
Suppose like I'm having a base product. Okay. On the top of that, at a given point of time, like I have 10 clients who are using this, my solution as services. Now the question is, suppose like one client asks for the changes in the base product itself. Okay, and lot of customization is required. Right. So don't you think like it might affect the rest of the 9 clients?
Then it's not that's why it's assess if the application fits in. The nature of customizations, does it need code level changes or does it need configuration level changes?
Okay.
Now almost anything you can make it configurable, but there's a cost to make it configurable. Like if you can identify all the scenarios of customization, you can make them all configurable. But then like you should again assess the bang for the buck.
Yes.
So it has to, the configurability should be said that multiple users can use at least some combinations of those configurations.
Okay.
It's not like all the configurability is done only for one client. Then you might have to go write a customized instance for them.
Okay.
So it's not like every application will fit into a SaaS model. Some may and some may not. If there's an extremely high level of customization involved, it will not fit into SaaS model.
Okay. And now another question is something like my solution, say like from one client perspective, and client is asking that they need to integrate with one more service. Okay. And that service is available somewhere, right? But other clients do not want it. And if I integrate my solution with that service, that might affect, like other.
No, it can't be a flat integration. See, this has to be configurable integration. So it has to. It cannot be a programmatic integration. Even if it's programmatic, there has to be an element of configurability where you can separate that.
Okay.
Integration is the easiest thing to handle. It is doable. But again, if integration is such that there's extreme programmatic integration involved, and it is different for each client, then yes, what you say is right. Then that's again not a SaaS-ready solution or SaaS, amenable solution.
Okay, thank you.
So it is a consideration. Like not all applications will fit into the SaaS model. Any other questions? Okay, thank you for patiently listening to me, and thanks to the organizers for the opportunity.